I got involved in this particular variety is simply because I've had a long-standing interest in fatty acid modifications that goes back to my previous jobs in canola breeding and even in sunflower breeding many years ago. So I've been working with fatty acids for a long time, and when I took this job in 1998, I became familiar with the genetic material that was developed by one of my predecessors, Dr. Gary Ablett. And what he did was he used soybean seeds to soak them in a chemical called ethyl methane sulfonate, or EMS. He wanted to develop soybean that wouldn't have to be hydrogenated for the oil. And one of the byproducts was a soybean with a very high level of linoleic acids. That's the linoleic acid is one with 18 carbons and 2 double bonds. And what we noticed that in this oil there was a significantly higher amount of linoleic acid, going from about 51% to 69%, and that's the highest recorded linoleic acid in soybean. So I became interested in that because I was involved with some chemical engineers in a project called the BioCar Initiative. So in that project I was told that an oil that would have a high content of linoleic acid with 2 double bonds would be of interest for them, particularly for the auto parts industry, because that oil is well suited for the polyol and polyurethane industries. And a lot of the interior car parts are actually using polyurethane foams, especially when one thinks of parts like seats, car seats. So from that point on, I had 2 students working on these fatty acid modifications, looking at the genetic control of them, the stability of the oil, the stability of the trait in the fields over a number of environments and years. And we came across one that was stable and high, usually around 68 to 69% of linoleic acid. It wasn't very high yielding, so we had to make crosses between that mutant soybean and soybeans that were high yielding, and in order to bring the yields up and closer to the yields of commercial soybean varieties. So my role has been in identifying the trait per se, talking to potential users of that trait, and bringing that trait into a better genetic background in my soybean breeding program at the University of Guelph.
The Catalyst Center is heavily involved in the marketing and commercialization of lots of technologies and varieties and seeds that come out of the University of Guelph research programs. With regard to this particular technology, the high linoleic soybean, our role is working with the researcher, Isfan Rajkan, as well as with Soy 2020 to develop strategies around approaching the market with this oil to give it the best chance possible to find a customer. We have several different end users testing the oil right now to see whether or not it works in their processes. If we get a lot of interest from them, the next step will be working together with Soy 2020 to find partners to grow the seed, to process the oil, and to be able to provide those to the end user chemical companies, industrial polyol companies, paints and coatings companies, to be able to put that into their processes.